Our next major feature of a vSphere cluster is vSphere HA, or high availability. We're going to be talking about HA over the next 3 lessons here. We're going to begin simply by saying what HA does. In the next lesson, we'll say how HA does its thing. And then finally, we'll look at how we configure our HA cluster. Well, let's dive right in and talk about what it is that HA can do for us. Okay? We'll look at the different options for configuring a highly available environment that includes HA. And we'll talk about here in this lesson what HA does in response to certain different types of failures. It's really important, and I've said it several times throughout the course of this lecture, that we avoid single points of failure in the entire environment. Okay? HA is one component of that avoids the ESXi host itself as the single point of failure. But there are other places. NIC teaming and storage multipathing can help to add support component failure in the environment. Things like redundant power supplies in your hardware, high quality hardware, redundant switches, configuring RAID redundancy within your storage arrays. All of those things can support failures of individual components. When it comes to your physical ESXi hosts, we have the ability to perform maintenance on hosts in order to avoid future failures with things like DRS in maintenance mode, as well as the simple vMotion being able to evacuate a host and shut it down. When it comes to storage itself, to be able to perform maintenance on our storage arrays by doing things like storage vMotion to evacuate data stores when we need to do maintenance on particular LUNs or particular storage arrays. When it comes to the actual data itself, we have talked about backup and replication and those sorts of things. And finally, when it comes to entire site disaster avoidance and disaster recovery, we have tools like Site Recovery Manager. So vSphere HA is just one component of this that we're going to dive in here. But we've spoken about most of this already. So make sure that HA is just one component of your entire disaster avoidance and disaster recovery plan. So what does HA do? Well, it actually responds to several different types of events. We can look at ESXi host failure itself. What happens? What does HA do when an ESXi host fails? Well, it simply restarts the failed virtual machines on living and working hosts. Okay? What happens if a virtual machine itself fails on a host that's doing fine? If Windows, for example, should blue screen? Well, what HA will do is respond by restarting a VM. It actually looks at VMware tools and receives a heartbeat coming down from VMware tools to know that a virtual machine itself is healthy. What about application failures? Well, there are a couple of corner cases where vSphere HA can monitor the state of an application and then restart the virtual machine upon an application failure. We are also going to monitor for data store accessibility features. What happens if ESXi loses connectivity to a data store? Say, for example, in a component failure with an HBA, or with a network failure in your SAN or Ethernet IP-based storage set of switches, right? Well, ESXi will detect that data store accessibility failure and restart VMs on hosts that do have good access to storage. We're also looking at network isolation, in that on our management networks, if ESXi loses access to management networks, and it's this management network that we're utilizing for a heartbeat mechanism so that each of our ESXi hosts can understand and knows that each other ESXi host is up and running. Well, what happens if we have a network failure, and how does HA respond to that? all of which we're going to be discussing in the next couple of lessons. So looking at an individual host failure here with ESXi, if we should happen to lose an ESXi host here and the virtual machines go down with it, what we're actually doing here is just finding remaining ESXi hosts and powering those virtual machines on the available hosts. I want you to note a couple of things here. We have vCenter server that manages this configuration, but it's the ESXi hosts themselves that do the operation using a management network, which is represented by this line here. Also note that we have shared data stores. Shared data stores are important that each ESXi host can see the virtual machine files. In this case, VM A and VM B need to be on storage that's accessible by the remaining ESXi hosts. Finally, if I restart this little animation here, note that there must be unreserved capacity across your cluster so that if in the event of a failure, the virtual machines will actually be able to be restarted on ESXi hosts, that they haven't reserved all of their capacity so that VMs A and B will actually be able to meet its network reservation requirements should any actually be set. Now, if a guest operating system should fail, we utilize VMware Tools virtual machine heartbeats to detect a failed guest OS and then simply to restart the virtual machine itself. This is a simple brute force restart of a VM. VMware Tools is the mechanism that we use to detect the stability of the VM. That heartbeat comes down to ESXi. ESXi doesn't ESXi then simply restarts the virtual machine after not hearing the heartbeat. Finally, we have an application failure. Now, this is a real corner case, and it's not often used. Here's what happens. We know that VMware Tools has the ability to communicate with an ESXi host. And if an application has been built to support VMware Tools application APIs, application heartbeat APIs, what will end up happening is the application sends a heartbeat to VMware Tools. VMware Tools reports that that heartbeat has been received to the ESXi host. ESXi knows everything is fine. If that heartbeat hasn't been received, ESXi will simply restart that virtual machine. So what happens if an ESXi host should lose connectivity to a data store where the virtual machines are stored? Well, I'm not sure what happens, but I can tell you it's nothing good, right? Well, why am I not sure? Because it can depend upon the application running in the guest OS itself. And it really depends on how long that outage might occur, for how long that outage might occur. We have two scenarios here, and we can respond to this data store accessibility failure in a couple of different ways. The first is a situation that we call all paths down. And all paths down is the state that your ESXi host's storage path exists in for the first 150 seconds of downtime. So for the first 2.5 minutes, ESXi says, I have no accessibility to storage. I've got virtual machines that are powered on, but I cannot read from the storage and I cannot write to the storage. What do we do? Well, the very first things that we need to think about is restarting the VM. Okay? Now, where do we restart it? Well, that depends on whether or not the storage comes back within that first 150 seconds. Okay? And we can configure this. And by default, we do nothing, by the way. Okay? But we can configure it if it comes back during an all paths down scenario to restart the VM either on the same host or on a different host. Okay? Now, after 150 seconds, after that 2.5 minutes, we consider that failure to be permanent. We call it permanent device loss, at which point we can configure how we respond. either to power off the VM and restart it on another host, or simply issue an event, or do nothing, right? Either way, we have the ability to respond in the event of a data store failure. Now, how do we protect VMs against network isolation? And the network that we're talking about here is the management network of your ESXi hosts. And we know that the management network is built with VM kernel ports. So each ESXi host has, by default, one management VM kernel port created. But if that management network, that physical network, should fail, then vSphere HA cannot properly operate. Because as we will learn in the next lesson, the heartbeat mechanism for vSphere HA occurs between ESXi hosts over that management network. So we want to avoid that network isolation where the hosts are isolated in their own island away from the management network by ensuring that there's redundancy in the management network. We simply will add another physical port to the management VM kernel port, or build a second management VM kernel port on each ESXi host. Now, if there's a failure on the management network, the ESXi host will attempt to ping its default gateway. And if it's able to ping the default gateway, it'll say, oh, there must have been another failure on an ESXi host because I'm now trying to do vSphere HA stuff. Again, we'll explain a little bit later. But if the ESXi host is unable to ping the management network, it considers itself isolated, okay? And it enters something that we call an isolation response, which by default is to do nothing. Leave my virtual machines powered on, leave everything as it is, wait for the management network to come back. Because after all, in many cases, our management network and our virtual machine networks are physically separated. So just because we have a management network failure doesn't mean our virtual machines are necessarily affected by that. Very important, of course, that we add redundant management networks. If there is a failure in the heartbeat over the primary management network, we'll utilize the secondary management port, okay, and attempt to send heartbeats over that, okay? Of course, if there is a failure on both of those, it could be because of one of two things. Either the host that we're trying to execute the heartbeat against has failed, or, of course, the management network goes down, and then we enter that host isolation response. So there's a couple of different ways that we can enable redundancy on the management network. If you're using standard storage, that is not vSAN, we use a VM kernel port marked for management. And we can either do this with NIC teaming, like we're showing here, a single management VM kernel port using two physical adapters. We'll use load balancing by virtual port ID in this scenario, okay? Or if we're using vSAN, then rather than using the management network for these heartbeats, we're actually going to use the vSAN network for these heartbeats. Either way, including, and at the very least, an active and standby NIC using NIC teaming is a good way to eliminate that redundancy in the management network. We can also, rather than doing NIC teaming, simply add separate networks with two VM kernel ports. So in this case, I've got two management networks, okay, two VM kernel ports using separate physical adapters. That's another way to introduce reliability into that management network. All right, so we understand what HA does, and we've gotten a little bit of a taste of things like heartbeats and network isolation. But in the next lesson, we're going to dive even deeper to all of the mechanics of vSphere HA. We'll talk to you about that really soon in lesson number 4.